Hello students, welcome back to our channel MathX Infinity. Today I am going to discuss a problem of complex number from IIT Advanced 2006. The problem is given as omega is a complex number alpha plus I beta where beta is non-zero and z be another complex number such that z not is equal to 1. And there is another complex number which is of the form omega minus omega over z by 1 minus z, which is purely real. Then the set of values for z will be uh, here is the four options. So students, we will solve this problem. First you should try this problem at yourself, then you can see this video. Okay, first students, looks omega is a complex number. Sorry, omega is a complex number which is of the form alpha plus I beta where beta not is equal to 0, and in the statement of this given problem it is clearly written that z not is equal to 1. If z is equal to 1, then this functions becomes undefined. I'm supposing this is z1, that is omega minus omega var z by 1 minus z. If z is equal to 1, then this given z1 will be clearly undefined. So uh, clearly we can say that uh, now students, before going to the another theory, first look at this the options. Option in the option A is it's given that z with modulus z is equal to 1. Okay, so this is option A. We can eliminate this option from our choices, because if this set uh, z with mod z is equal to 1 contains the number z is equal to 1, which is excluded from this statement. Okay, so options we can pull out option A from our choices. And if we now we look the option B. In option B, it is given that uh, z is the set of complex number where z is equal to z bar. So students, clearly we can say that z is purely real, because z is equals to z bar. So I can we can assume z is equal to 0, then z1 becomes z1 is equal to omega minus, since we can assume z is equal to 0, that is 0 by 1 minus 0, that is omega. And what is the form of omega? Omega is clearly alpha plus I beta, and which is non-zero. Beta is non-zero. So z1 becomes an imaginary number, but in the given problem it is given that this complex number, which we let this as z1, is purely real. But if we take from the condition of B, that z from this condition B, z is equal to 0, then z1 becomes imaginary. So option B is incorrect. Okay, option B is incorrect, since z1 is a imaginary number. Now students, we will go for the other options. Um, in option C, just look at this number z with all set of numbers with z not is equal to 1. We can use the same trick for option C. Since z not is equal to 1, we can assume students z is equal to 0. and then clearly z1 becomes an imaginary number, which is a contradiction, as in the given statement it is given that z1 is purely real. So there is only one option left, students, for us, and the correct option is option D. This is the only correct option. Okay, option A is incorrect. Option D is incorrect. So this is the one of the now, students. We will take option D more theoretically. Okay. In option D, it is given that so the set of all complex number with mod z is equal to 1, and obviously z not is equal to 1. Students, look that uh, it is given uh, that this complex number, which we have let it as z1, this complex number is purely real. So we, since it is given, this is the given in the statement that z1 is purely real, we can assume, we can say z1 is equal to z1 bar. Okay, so what is my z1? Omega minus omega bar z by 1 minus z. And what is my z1 bar? Omega bar minus omega z bar 1 minus z bar. Okay. Now we will do some simple calculation. Omega minus omega bar z, omega z bar plus omega bar z into z bar, omega bar omega z bar minus omega bar z plus omega z z bar. Clearly, we can eliminate omega bar z and omega z bar from these two sides. Now we can write omega minus omega bar equals to omega z into z bar minus omega bar z into z bar. Okay, so just omega minus omega bar z into z bar. Since omega is of the form alpha plus I beta, omega bar will be alpha minus I beta, and omega minus omega bar will be 2I beta. And since beta is non-zero, as given in the statement, so omega minus omega bar also non-zero. So we can eliminate this two term out, as this omega minus omega bar is non-zero. We can eliminate this two term. So z into z bar is equal to 1, and so mod z square is equal to 1, and therefore mod z is equal to 1. So there is the easiest way to check that z is a complex number which satisfies this, and obviously z not is equal to 1, and so the correct option is option D. So I think, students, you can understand this problem, and if you have any query, any question, you can ask me. Thank you.